Okay, so in this lecture we're going to talk about writing and naming compounds with transition metals. Okay, transition metals is going to be all of those d orbitals that we were talking about before in electron configuration. So that's all these right here. Okay, this is going to be my d orbital. And we're going to be able to name and put charges on our d orbital. Remember from the periodic table, transition metals can have more than one charge. Okay? So you have to know which charge it is, and you have to express that. You have to tell people what charge it is, because it could be anything. It could be +1, +2, +3, +4. It'll never be negative, but it's always a different positive. All metals except group 1A, 2A, silver, cadmium, and aluminum, and zinc have more than one charge. So let's talk about the ones that always have charges. My group 1A. That's going to be, if you look on your periodic table, make sure you have one. If you look all the way to the left, there's hydrogen, lithium, sodium, potassium. All that's my group 1A, and we know that all those have a charge of +1. Okay? Group 2A, we know that group 2A, that's the one that has beryllium, magnesium, calcium, strontium, barium, and radium. All those have the same charge, and that is +2. Silver, I told you have to remember because it's always the same. That one is +1. Cadmium and zinc. Now find those. Number 30 and number 48. Those are transition metals, but they will always have a +2 charge. And the last one, aluminum, you should know what aluminum is. That's a +3. Okay? Aluminum and boron, that whole row is +3. Alright. So, pause the video real quick and circle all the metals listed below that need Roman numerals. What does that mean? Basically circle all the ones that we did not talk about in the previous slide. Okay, so circle all of them. I'll give you a minute. All right, your minute's up. Okay, so here we go. Calcium, that's in group 2A, so no. Nitrogen, that's in the 15th group, so no. Copper, yes. Francium, that is number 87, so no. Zinc, that is a transition metal, but remember I said that that one always has a +2 charge, so I don't need Roman numerals for that. Nickel, yes, number 28. So here, I'll put the numbers. Number 29 is number 28. Manganese, look, this is not magnesium. Those are two different elements. Manganese is number 25, and that is a transition metal. Magnesium is number 12, and that is not a transition metal. Now we have lead. Lead is an exception. That's number 82. That is also going to need Roman numerals. Okay, it's not quite a transition metal, but it still needs them. Iron, yes, number 26. Aluminum, no. Mercury, yes. And that is number 80. Tin, again, that one also needs Roman numerals because it could be a bunch of things. +2, +4, +3. This one is number 50. Silver, yes. Oh, I'm sorry. No. Silver is a +1 always. Do not circle silver. Rubidium, number 37. That is in group 1A, so no. Chromium, yes. That is number 24. Lithium, no. That's number 3. Zirconium, yes. Zr, number 40. Cobalt, yes. Number 27. Barium, nope, because barium is number 56. Gold, yes. That is number 79. Okay? So you need to know the differences between when you put Roman numerals and when you don't. Okay? All of these up on this board are all positive charges, meaning they are all going to lose electrons because they're all metals. Metals lose electrons, so they're all going to have a positive charge. Ooh, there it is. Okay, we're going to write the formula for an ionic compound containing a transition metal. The first thing you should do is write the metal. We've done that before. That means the positive, the cation, first, and its charge. If it is a transition metal, the charge will be specified in parentheses after the element. Remember, parentheses, if you don't know what parentheses are, they look like that. Step 2, write the nonmetal, the anion, and its charge. The nonmetal may be a polyatomic ion, so remember, if it's a polyatomic ion, you just name the polyatomic ion. You look on the back of the periodic table for the name. So let's look at the example. So we have 2 here. It's fine, I'll just show both. Let me get a periodic table. Go. Here I have iron 3 oxide. Okay? So iron 3 oxide. Let's break it up into my positive and my negative. So I need to know what my cation is. So on the side, just write cation. So which one's my positive? That's going to be my iron. Okay? That's going to be Fe. Right here is a Roman numeral. Okay? You should be able to remember what you should be able to know what Roman numerals are. If you're having trouble, you can ask a partner or look it up, or you can come ask me on Monday when I'm back. But iron has a 3 there because there's 3 lines, so that is a +3 charge then. Oxide, that's going to be my anion, and that's oxygen. Oxygen is number 8 on the periodic table. You should know that that's a -2 charge. Okay. Now that I have my charges, I have my cation and anion, I'm going to cross my charges. So now I'm going to have for my compound Fe2O3. Okay. Let's look at the next one. Next one, mercury 1 fluoride. So let's go with cation first. That's my positive. That's going to be my mercury. You're going to have to find mercury on the periodic table. That's number 80. That's going to be Hg. And since there is a 1 here, that has a +1 charge. My anion will be fluoride, which is also fluorine. Remember, I just changed the ending to IDE, but it's fluorine. Letter F. What charge does letter F have? A -1. I'm going to cross my charges. I have a 1 here and a 1 here, so they're going to cancel out. So I just need to write HgF, and there's my formula. Okay. Write the correct formulas for the following compounds right here. Let's do the first 3 together, and then you can pause the video and try the next ones on your own. So let's write cation, anion. Okay. 10,4. Okay, that's going to be my cation. 10 is number 50. Now this one's a little tricky. It starts with a T. It has an I and it has an N. Yet the symbol is SN, number 50. You really have to find the element in order to put the symbol. This right here, this part right here, this is an IV. That also stands for 4. So that is a +4 charge. Chloride is my anion, which is Cl, chlorine. And we can look on the periodic table. That's in my 17th group. That is a -1 charge. I'm going to cross my charges. There. I'm going to cross them, so I'm going to get my formula SnCl4. Let's try the next one. Here I have lead 4 oxide. So my cation is going to be lead. If you need to find lead, number 82 Pb. And that has a +4 charge because of the 4 right here. The 4. That's where I'm getting that from. And then my anion. And that's going to be a -2 charge. Now I'm going to cross my charges. Now watch what I do here because it's important. I'm going to get Pb2O4. Now remember what I said. If you can simplify it, you need to simplify it. So I have a 2 and a 4. I can divide both of those numbers by 2 because I can simplify it. And my formula is going to be Pb, let me write it better, PbO2. And that's the formula. Okay? If you can simplify the answer, simplify it, please. So the next one, 10-2. See how I have 10-2 here, but on number 1 up here, I have 10-4. Okay? 10 can be multiple charges. That's why it's a transition metal. So cation is going to be 10. We said it was Sn. Now we know it's a +2 charge. Anion of sulfide. That's another word for sulfur. So that's S. And that has a -2 charge. Cross my charges. So my charge will be SnS. Now I'll have a 2 and a 2. Now can I simplify the 2? Yes, so you can divide them by 2, each of them. And so the actual formula is going to be SNS. Sorry, I ran out of room. Okay, pause the video now, and I'm going to go through these next 3 quickly and try them on your own. Try to do the next 9 on your own. Okay, you should have paused the video. I'll do this one quickly. Here I have mercury 2. That's going to be Hg. Oh, I'm sorry, this is my cation. There's a 2, so this is a +2 charge. My anion will be bromide, which is Br, -1. Cross my charges. I'm going to get Hg, Br2. Next one, I have copper 2. That's going to be Cu. This is my cation. And it has a 2 there, so it's a +2 charge. Nitride, IDE, so that means it's an element. So anion, and it's going to be nitrogen. Nitrogen is in the 15th group that has a -3 charge. Cross my charges. And then I'm going to get Cu3 in 2. Okay. Next one, barium iodide. My cation here is going to be barium. That has a +2 charge. My anion is going to be iodide, -1. Cross my charges. And that's going to be BaI2. Okay. Let's move on. Here I have iron 2 carbonate. There's iron 2. So let's find iron 2. Iron is my cation, and that is Fe +2. My anion. Now this says 8, carbonate. That's a polyatomic ion. Look on the back of your periodic table where it says polyatomic ions. Go to carbonate, and that is going to be CO3 -2. I'm going to do this a little simpler. This is +2, this is -2. That means they're going to cancel out when I put them together. So my formula is going to be FeCO3. Now you can cross the charges and simplify, that's fine, but this makes it a little bit easier. Let's try this one. 10, 4. 10 is my cation, and that is Sn, and that has a positive 4 charge. My anion is nitrate. There goes that word 8. Look on the back of the periodic table where it says polyatomic ions. NO3, -1. Cross my charges. I'm going to have 1 Sn, and I'm going to have 4 nitrates, 4 of them. So you need parentheses. 4 nitrates. Last one. Copper is my cation, and that is Cu. That has a +2 charge because of the +2. Phosphate, here goes my 8. So that's going to be my anion. Let's look at the back of the periodic table to the polyatomic ions. Phosphate, PO4, -3. Cross my charges. I have 3 coppers, and I have 2 phosphates. Okay, remember, you're going to keep those all together. 2 phosphates. So I need parentheses. PO4, and I have 2 of them. Okay. Now when you're naming them, it's a little bit different. Okay, we took the charge and we saw the charge in there. Now we just need to put that charge back in there. So you're going to name the metal followed by a Roman numeral in parentheses to indicate the charge of the metal. An example, copper +2, right here, copper +2. You need to write copper and then a Roman numeral 2 to emphasize the charge. Figure out the charge of the nonmetal, and the overall nonmetal charge has to be equal to the charge of the metal. I'm recording. Figure out the charge of the metal and the nonmetal. Name the nonmetal with the suffix IDE and write the name of the following compounds. So try to do the next 2.
Can you do me a favor? 7th period of
No.
We don't have 7th period. We have the list.
Ask Bush. I think she might have 7th period on.
No, she doesn't.
Oh, she doesn't? Oh, I don't either.
Thank you. Sorry.
Yeah, no problem. Alright, so right here we're going to write the name of the following compounds. Sorry about that. Here I have CuCl3. Okay, so this is copper and chlorine. For these you need to find the charge of the nonmetal, chlorine. Chlorine has a -1 charge, but how many chlorines do I have in this problem? I have 3 of them. 3. So, in order for there to be 3, I need to have a total. So if I have, okay, I'm sorry, let me rephrase. Chlorine has a -1 charge. There's 3 of them, so in total there should be a -3 charge. I need to cancel that out with copper. So copper then needs to be a +3 charge. So to name it, I'm going to put copper. 1, 2, 3. And then chlorine, but remember you changed the ending. Chloride. So I still changed it to ide. Let's try this one. Oxygen is a -2 charge, right? And I only have 1 of them, so it's a -2 overall. 10, I need to cancel out a -2, so 10 has to be a +2. So it's going to be 10, 2, oxide. Oxygen, I still changed the ending to oxide. Let's try to do a couple more. These are a little more trickier. Here, chlorine has a -1 charge, but I have 2 of them. So in total, it should be a -2 charge. So I need to cancel it out with iron. Right here. I need to cancel it out, so that's a +2 charge then. So the name of this is going to be iron 2 chloride. right here. Oxygen is a -2 charge. There's 3 of them here, as you can see. 3 of them. So you have to multiply times 3. So let's multiply times 3. That's going to be a -6. So I have to have a +6 on this side to cancel it out. But how many irons does it say I have? It says I have 2 irons. So since I have 2 irons, you have to divide by 2. So the charge of each of the ions will be +3. I know this may be a little confusing, but you want to get the totals done. So here, -2 for just 1 oxygen. I have 3 of them, so now I have a -6 charge. I need to cancel it out, so I put a +6 on this side. But I have 2 irons, so now I have a +3 charge. Okay. So the name of this one, I'm sorry, I didn't do the cation and anion. The cation, so it's going to be my iron +3. My anion will be oxygen -2. And the name is going to be iron 3 oxide. All right, so the next one. This one, Rb. Is Rb even a transition metal? It's not. It's number 37 on the periodic table. Always check to see if it's even if it's a transition metal. Since Rb is a +1, always, and chlorine is a -1, do not put Roman numerals. You only put Roman numerals when it is a transition metal. That's not the ones that we know. So this one is just the name of those 2 elements. So that's going to be, so my cation is going to be rubidium, Rb +1. My anion is chlorine, Cl -1. The name, rubidium, chlor, wait, did I spell that right? Yeah, Ide. Still change it to Ide. Okay. I want you to try these next ones on your own, okay? Now really, really try to do these on your own and play the video when you get stuck. Okay. We'll start with this one. Hg is going to be my cation. I is going to be my anion. I has a -1 charge. I have 2 of them, so in total it's going to be a -2 charge. Over here I have to have a +2 charge. Now I have 2 mercuries, so I divide 2 by 2. And each of the mercuries is going to be a +1 charge. So this is a +1, and this is a -1. To name it, it's just going to be mercury 1. I'm just kidding. Iodide. Iodide. Next, I have Cu and CrO4. Cu is copper, and CrO4 is what? You gotta look for a polyatomic ion here. Go to the back of your periodic table, find CrO4. It's called chromate. So my anion is going to be chromate, CrO4, and that has a -2 charge. My cation is going to be copper. So this all has a -2 charge. There's only 1 chromate. There's only 1 of them. So -2. I need a +2 over here, and there's only 1 copper, so it's a +2 charge. So the name over here is going to be copper 2 chromate. Remember that we do not change the name of the polyatomic ion. We just write it. Next one. PbO2. Oxygen has a -2 charge. There's 2 of them though, so that's a -4 total. Pb has to be a +4 then. And so my cation is Pb with a +4 charge. My anion is oxygen with a -2 charge. Pb is lead 4. The way you write 4 is 1b. And then oxide. Next ones. Here are the last 3. My cation and anion. Cation here is going to be copper, and my anion is going to be the rest of it, SO4. Now that's a long one, so that must be a polyatomic ion. Flip over to the back, look and find SO4. Sulfate has a -2 charge. -2. There's only 1 sulfate, so that's -2 total. So copper has to be a +2 then. +2. So to name it will be copper, and that's going to be 2 sulfate. Okay. Next one. I have NO3, NO3, and Fe. Fe will be my cation. NO3 will be my anion. NO3 is long, so it must be a polyatomic ion. Look on the back of the periodic table. NO3, that's nitrate. So that has a -1 charge. -1. Now, you should ask yourself, how many nitrates do you have? You have 3 of them. So in total, that's a -3 charge. So iron has to be a +3 charge. Because it has to cancel out. So this is a +3. So the name of this one is going to be iron 3 nitrate. Last one. Mn is going to be my cation. OH is going to be my anion. OH, that's 2 elements. It must be a polyatomic ion. Go to the back of the periodic table. Go down to OH, hydroxide. That has a -1 charge. Okay, so I have a -1 charge, but I have 2 hydroxides because there's a 2 here, as you can see, 2. So it's in total -2 charge. That means manganese, Mn, has to be a +2 charge. So it has to be a +2. Remember, this is not magnesium. This is manganese. So the name of this one is going to be MANGANESE. Has this 2 charge, 1, 2, and then finish it, hydroxide. Hydroxide. Because that's the name of the polyatomic ion right here.